Students, in the previous class we have discussed about Thomson's atomic model. Now in this class let's start Rutherford's experiment. Clear? This experiment was performed by Hans Geiger and Marsden in the year 1911 in Manchester University on the advice of their teacher Rutherford in order to know the exact structure of atom. This experiment is popularly called as Rutherford's gold foil experiment or Rutherford's alpha particle scattering experiment. Clear? So, let's see. The experimental arrangement of Rutherford's alpha particle scattering experiment is like this. The experimental arrangement consists of 6 components. First one is a lead box having a very fine slit. First one is. And the second is a radioactive substance polonium which radiates alpha particles spontaneously. Then third one is collimators made up of lead. Then next one is a thin gold foil having thickness 4 micron. Then next one is a rotatable zinc sulfide screen which surrounds the gold foil. And the last one is a detector. Clear? Then these components are arranged in Rutherford's experiment. Then how they are arranged in the experiments? Let's see. Here the radioactive substance is taken inside this lead chamber having a very fine opening, and the radiation of alpha particle emitted by this radioactive substance is now allowed to incident on this thin gold foil after passing through these collimators. Clear? And after passing through the gold foil, the ejected alpha particles are detected with the help of this microscope or this detector. Clear? When these alpha particles strike the zinc sulfide screen, they produce scintillations or white illumination or white glow. So they can be detected with the help of the detector. Clear? From this experiment, they observed that first one is, suppose this is the thin gold foil and the alpha radiation is incident on this thin gold foil, and they observe most of the alpha particle passed through the gold foil without suffering any deviation. Clear? Some alpha particles scattered through smaller angle deviation, theta less than 90 degree, small angle deviation. Some alpha particles scattered through large angle deviation. A few alpha particles, 1 out of thousands, suffered large angle deviation, that is theta greater than 90 degree. Theta greater than 90 degree. And a very few alpha particles, 1 out of 8,000, returned back. That is back scattered, that is theta is equal to 180 degree. Clear? Here theta is the angle of scattering of alpha particle after passing through the gold foil, and n theta is the number of particles. N stands for the number number of particles scattering through an angle theta. Theta is the angle of scattering, and n theta is the number of particles scattering through an angle theta. And the relation obtained is n theta proportional to 1 by sine to the power 4 theta by 2. Clear? And if a graph is plotted between theta and n theta, then this type of graph is obtained. Here, this is the theta axis and this is the n theta axis, and the graph is like this. Clear? Let's see. This is the observations. These are the observations. From these observations, they conclude that, see here, since most of the alpha particle passed through the gold foil without suffering any deviation, it indicates that maximum portion of the atom is empty. Clear? Since most of the alpha particle passed straight without suffering any deviation, that indicates maximum portion of the atom is empty. Clear? This is the first point. Then the second point is, since some alpha particles are scattered, that means they must be repelled by some positively charged object situated inside the atom, since alpha particle is positively charged. Clear? And third one is, since a very few alpha particle backscattered, that means there must be a very tiny positively and a heavy object situated inside the atom, for which very few alpha particles scatter. These are the conclusions drawn from Rutherford's experiment. Clear? And Rutherford put forward a theory on the basis of these conclusions, which is popularly called as Rutherford's atomic model, which can be discussed in the next class. And the detailed course note of Rutherford's experiment along with Rutherford's atomic model will be given in the description box in the next video. Thank you for watching with patience.